you have to multiply this by 512 and this by 512. Yeah? Yeah, so yeah. We're not going to act like this isn't. It really is. So this will be 3584. My God. And then the other one is 0, so we don't have to worry about that. Yeah. Yeah, this is only when you want to be curious and see how far you can go with this. So when we add up everything, we're supposed to get this number, 3692 over 32768. Yeah. And yeah. Let me see now. Really? No, star, listen. You just do the calculator move after this. Right? Because we can actually, do that, but I don't have time for this now. I mean, again, I could prove that. Even without a calculator, I can get us to where we want to be, right? Because we have to do this. We never have a choice. Each number is multiplied by a power of 8, which is in the inverse. So you have 0 times 1 over 8, 7 times 1 over 64, 1 times 1 over 512, right? 5 times 1 over, so yeah, this was kind of ridiculous. It was. So we're not gonna further on that. I won't. Right? If anybody set a question like that for you, them just want to take up your time. Right? So let's do something a little bit more practical. Like, okay, the real ones, like 57632, and that is in base 8. Right? So make we stay. Or you know what? Even alright, this not so bad. If they may give you something like this, and then this was in base 8, this wouldn't so bad, to be fair. So therefore, I forgot to do this, I forgot to do this. And I apologize for that. So after 1 times 8 and then 64, 512, then 4096, and then what do you come after that again? I think it was 32768. Yeah. So okay, so let's put it in context, right? So that we'll understand where this should be. If we were to add this to up here, then the 0 would be here. And this is where the rest of that would be. Right? So just imagine that this would be a and both of these numbers are in base 8. So then this would be in base 8, this would be in base 8. Right? So that is why let me put this up now. So therefore this is 8 to the 0, 8 to the 1, 2, 3, 4, and then this now, when you go over here now, minus 1, minus 2, yeah. So that is why that makes sense. So if you so for example, if you just got this, if all you had was this, then the first thing you want to do is start off this by writing 8 to the 0 first. Right? So one set is to the left of 0 and another set is to the right of 0. So you're going to the right of 0 now, you start going in the other direction now. So you have 8 to the minus 1, 8 to the minus 2, 8 to the minus 3. Right? And I guess it makes sense you work out something like this beforehand, so that way you're not trying to figure it out when you get, if you ever see the question for the first time in your life. Because in all seriousness, I've never taught this. Rather, I don't even remember getting a question like this. I always get the whole number versions of the base numbers, but to get them in this form, kind of crazy. All right. So 8 to the minus 1 is 1 over 8. Right? Oh, see? So I did this, but I forgot to go in the other direction. So maybe I should do that. Maybe I should do that. So if I'm going back now, I must write 1 over 8, 1 over 64, 1 over 512, 1 over right. So let's see. All of a sudden that now work. What's going on? Alright. Let me see if I can yeah, I want to make sure that all of that is visible. Right. So therefore this would be a 0. This would be our minus 1, minus 2, minus 3, minus 4. This would be your 1, 2, 3, 4, 5. So this way we don't make any mistakes, right? So we're not going to multiply this by 8, this by 64, this by 512. It's the inverse of them, right? So therefore the first number is 6 times, 7 times, and 3 times. So therefore 6 times 1, hold on there, 1 over 8, so you have 6 times 1 over 8, 7 times 1 over 64, and 3 oh yeah, 3 times 1 over 512. Just make sure so we'll have that. And then of course, now the LCM of 8, 64 and 512 is going to be 512, right? So if 8 raised to the 3 is 512, that means I have to multiply this by 64 and this by 8. So okay, let me do this then. Let me try and represent them so that they are visible now. So this would be 6 over 8. This would be 7 over 64. This would be 3 over 512. Then after that now, the base for all of them, or rather the LCM of all of them would be 512. So we'd have, I don't know, hold on. I'm gonna put these in blue. So what? 64 times 6. I made it that now. Alright, so that's 384. So I have that. We have 7 times 8. So okay, this is multiplied by 64, this by 64, this by 8, this by 8. Alright, so 6 times 64 give us that, 7 times 8 will give us 56. And of course, this don't need to change. You can just multiply that by 1, that by 1. So this is just, yeah. Yeah, this is a lot more, what do you call it? A lot more tedious. let me see now. 384. And we add that to, yeah. So, when everything is said and done, we end up with 443 over 512. And then with that now, obviously you turn that to a decimal after the fact, which, listen man. This is just a test of your patience, really. And you have to be careful, right? The only good thing is that you know that the denominator go unchanged. So you just multiply the 6 by 1, you have 6 over that. 7 by 1, 7 over that. 3 by 1, 3 over that. Right? So 6 by the 1 over 8, 7 by 1 over 64, 3 by 1 over 512. Right? So we move from this to this, right? Then we find the LCM of the 3, which is the largest one. So we're not even have to guess that part. And then we make them all equivalent, and then we add it together. So therefore, when we put all of these 3 together, we end up with that. And you know the crazy part about it, this is supposed to be one of the easier one thing. Right? Once it passes 3 decimal like three numbers behind the decimal point, we're not going further than that. Not going no further than that. But yeah, this is just in case you're ever in the situation where you need to be able to do this, right? You know, so yeah. But in the other case now, you don't have to worry so much about that because you don't have any fractions to deal with, right? So in this case now, up here, where all you have is the whole numbers, right? You just, so therefore 8 to the 4 now is what? 8 to the 4 is 4096. Then to the 3 is 512. Obviously, this is just 64. This is just 8. And this is your 1, right? So 1 here, 8 here, 64, 512, and that. So this will be 2,480. Then we have 512 times 7. Alright, so that's 3,584. And you have 64 times 6. So now you have 384. Oh, that means I need to bring it down a little more than that. Now 3 8's 24. And then the last one, 2 times 1. Yeah, that's it. So now I have 26 plus 3, 84. 410 plus 35, 84. And then we just take that and add it to 20,480. So in total now we have 24,474. So that's what this would be in that's what that would be in base 10. So you know, you see, it's clearly a lot easier when you have the whole numbers working with. When you start going down the decimal path now, you're starting to deal with fractions and all of that now, right? So we can do the reverse. I believe we can do the reverse. So let's try. So this was. So let me write it up here. This was base. So this is base 8 to base 10. So now we're going back. Right? So we went from base 8 to base 10. Now we'll go try and go back. So imagine we never know all of this up here. And what they gave us is a normal number. The number 24,474. How would we convert that now to, how do you turn this into a base 8? So, alright. So let's start off with our 32,768. Drop it to 4,096. Drop it to 512. Drop it to 64. Drop it to 8. And then drop it to 1. Alright? So let's see. 0, 1, 2, 3, 4, 5. So we have 5 here, 4 here, 3 here, 2 here, 1 here. Alright. Now, this number smaller than this, so we're not even going to entertain that at all. Right? So we can't use any amount of 8 raised to the 5, because that will not be smaller than this. So now we have to figure out how many 4,096, how many of this number we can fit into this. Right? How many? I mean, you can do it in the calculator. So let's actually, if you have a calculator, then here we go. The amount would be something like this. Now, if we round it off, normally you'd probably want to round this up to 6, but in reality, because the maximum is 5, you just leave off everything else. Right? So in other words, hold on. Let me see. Yeah, see? Yeah, exactly. Because if you multiply this number by 6, you're going to end up with a number larger than 24,474. So we can't use this. We can't use 6 of them. So we don't have to use, yeah, because let's say we did do this. If we subtract that number from, so watch it now, 24,576, right? 24,576. So let me do that. 24,576. See that? Yeah. We'd end up with something negative. That wouldn't make any sense. You get me? So really and truly, even though normally we want to round the number up, if we divide the number 24,474 and we divide it by 4,096, it means that we can only get 5 of 4,096. Everything else will just be a remainder. So we'll just ignore the remainder part then. Right? And we can do this manually, but obviously for save time I'm gonna do that another time. So that means we'll multiply this number by 5. Right? So when we do that now, we get 20,480, so we'll go subtract it from this. 20,480. Alright, so let me put it down here so now. I'm gonna ignore them two there. Right? Let's ignore that. Now if I took 474 from both of them, I'd end up with this. 474 from that would leave me with just this. So add 4 to that, 9 to that, 9 to that. Yeah. Yeah, so my result would be 3,994. So I'm going to put that up here. And we can do that manually and see how that would go. Right, so yeah. Right, so now so if we were to actually divide, if we divided this by 4,096, we'd end up with 5 with a remainder of 3,994. That's probably what would that's very much likely what would happen. Right? That is very much likely what would happen. So now we have 3,994. Now we have to work with 512 and see how much of that can fit into that. Right? So let us see. 3,994. Alright, now watch this. Much like what we had before. Yeah? So let's just say we have 5, 6, 7, 8. And the number drop between the 7 and the 8. Once it drop between 7 and 8, we just go dash away everything to the right of the decimal. And we'll go focus on what's on the left. So it don't matter. If it's not exactly 8, then we can't use it. Right? So we have to treat it like we're using like whole number integers. Right? So it's either 7 or it's 8. And if it's not 8, then it is 7. So nearly is not good enough. You understand? Because if I multiply 512 by 8, it give me 4,096. Right? But yeah, this number is smaller than 3,994. You understand? But this number is bigger. So for example, we couldn't use it because anyhow me do this and I do this. No, what may I do? 4,000. Yeah, see? Yeah, end up with a negative number again, right? So it's clear that I have to use what? 512 times 7, right? 512 times 7. Yeah? So I'm going to put 7 times that, and I'm going to subtract it from 3,994. So 3,584 now. This look easier. 9 minus 5 is 4. 9 minus 8, 1. Alright, we have 410. Now again, how many 64s we can fit in that now? So 410 divide that by 64. Again, it drop over the 6. It's not quite 7, so it's going to be 6. Alright, so if it go a little bit over the 6, it's going to be 6. Alright, just like how, you know, you can't have 6.40625 people. It's either you have 6 people or you have 7 people. Alright, you know, go find the fraction of a person or something like that. That doesn't make no sense. Alright, so it's either you have 6 people or you have 7. You can't have 6.5 or 6 3/4 people, you know. No. Right? So we're going to say that we're multiplying 64 by 6. Right? 64 by 6. because that gives us a number smaller than 410.